we'll get started, okay? So last time the textbook, we are on the functions, okay? So today I'm trying to finish up the chapter 7 and 8, the decision structure, the if then else, and also the so-called chapter 8, the loops, okay? Because it's not really difficult. I'm trying to learn about these two chapters, and there are more chapters, so we will do more. But in terms of data science, this week we will work on the following. The past 2 weeks, we are actually teaching you two things. We teach you how to draw pictures. So we actually teach you Excel, and then we teach you using Excel to draw charts. Not me using typing, okay? It's actually the drawing is always not good. So that's 2 weeks. We teach you Excel and then teach you charts, okay? That's 1 week. And then another week, we teach you actually MapRight and also more charting, okay? More charting about how to draw bigger chart and then put in the labels on it, put in the axis like on it. Okay, so basically so far these different things teach you how to, when you got data, how you represent it. Okay, that's actually charting. So we teach you data science on charting. That's last 2 weeks. What we did the last 2 weeks. Okay, so this week, in terms of data science, we will teach you more functions, more math, then how to use math to model your problem. So that's actually when you go to high school, you do learn your pre-calculus. Let me use typing. Actually, this is not good. So you learn pre-calculus, you learn functions, you learn trigonometries, you learn linear algebra. Okay, you learn different things, but these different maths, you learn it in math level, and then you need to learn programming to realize these different functions, and then these different problems, you may also map the problems to solve the problem in physics, in finance, in different world. Okay. So here today we will actually teach you more of the mathematics right here. Okay, the more in the mathematics. Okay, that's what we would do today. And then try to understand it in terms of the math, okay? So let's go back to the function. So to model a function, okay, so basically you got a mathematical function and you want to run it or you want to model it. Okay, so the very intuitive way of doing that, let's call it polynomial one, okay, poly1, that py, polynomial one. Okay, the very intuitive way of doing a polynomial function is you define some function called poly, right? And this polynomial function, you do have coefficient, let's call it C, and then you will have X. So this is C and X representing, let's assume that this C is a list. X is a number. Okay, so you do have, let's assume that you have C2x squared plus C1x plus C0. So this C will totally have, let's assume you have a Cnxn down to C0. You totally will have n plus 1 term because you have a 1 to n also have a 0 term. 0 term is C0. There is a X0 term, right? Is that okay? Hello? Is that okay?
Yeah.
So let's assume this is that, and you would evaluate this function. Okay, you evaluate this function, so you are going to have a sum. So sum equals 0.0. At the end, you return the sum. Okay. And then you will try to actually calculate you will do calculation of this. So you do for the I equals this one was starting from let's see. Okay, I in range. You starting from C to the the length of C. Okay, and then down to let's see. So that's assume you have let's see, you have C2 x squared plus C1 x plus C0. Okay, so this is totally you have 3 terms. Your C should have a length of 3, and you actually represent an order of 2, right? So you actually your I should be starting from here, actually starting from, let's see, so starting from the length of the C minus 1 down to minus 1, not including minus 1, and jump by minus 1. Okay, and then let's print your item. Okay. Let's print your item. Okay, so print your I. And then let's actually do this. Let's do poly. Of your 1 to 1. 1 to 1 means this one is actually C2. Okay, so it's x squared plus 2x plus 1. Okay, and that is f of x equals x squared plus x plus 1. So that's assume that you are trying to find f of 2. Okay, so this x you evaluate the 2. And then this one, let's do F2. Okay, this is the value of F2. Let's assume that. Okay. And right now, I directly return sum of the zero, so it actually is the wrong number. So it's a print now of the F2 is of no purpose, of no use. Okay, it's actually is a fake one. Okay, it's a fake one, but I try to print out every I. Okay, every I. Let's look at the I that it goes through. Okay, so clean it. I just want to know about the I value. Okay, it's wrong it. So the I goes to 2, 1, 0, that's no problem. And sum is 0.0, there's no problem. Okay, this one is okay. Let's actually continue. So this one, we are going to calculate the sum. Sum means it will be evaluate f of 2 on the function. Okay, on the function. And the function right now is x squared plus 2x plus 1. Okay, so what you will do is actually, this is C2. Okay, so first one, you assign the C2s to the sum. Second one, you actually do assign C2 times x plus C1. You assign this to the actually to the sum. And then third one, you have the C2 plus x times C1 times x plus C0 assigned to the sum. Okay, so then this sum will be C2 x squared plus C1 times x plus C0. Is that okay?
Yeah.
Knowing what I'm saying right now?
Yeah.
Okay. So that is the way we would write it. So to write this function, what we would do right here is sum equals sum times x plus c's i's value. Okay, so this print out all the links will not be do. So let's look at this one. So again, we have a C2, C1, C0. This is C2 x squared plus C1x plus C0. Okay, this is the f of x you would evaluate. Okay, so first round you have C2 is 2, 1, 0. Okay, so your C2 is the I you look at. So basically your sum is 0.0. So you have 0 plus C2, that's your new sum. Okay, so next round, your sum is C2 now. So C2 times AX plus C1, you assign to the sum. So next one, you have the C2 times X plus C1 times X plus C0 is the sum. So this is I equals 2. This is I equals 1. This is I equals 0. And you do counting, so you would number from 2, 1, 0 using this ranging function. So eventually you have to get a sum, okay? So that's no problem. This one will calculate your evaluation of the function without any problem, okay? So here again, I'm teaching you how to write a polynomial functions evaluation function. Okay, so this one give you the F2. So let's look at this F2's value now. Let's actually run it. And F2 got 9.0. Let's look at it. It's C2 times 2 squared plus C1. This is 1. This C1 is 2 times 2 plus 1. So you got 4 plus 4 plus 1. That's actually 9. Okay. Now let's try another number. Let's try f of 3. Let's try f of 3. F of 3 equals polynomial function of the 1, 2, 1. Okay, and then 3. Okay, that's f of 3, and then we put in f of 3. Okay, let's save it. This is polynomial function. And then you've got 16. 16 is 1 times 3 squared plus 2 times 3 plus 1. This is 9 plus 6 plus 1. You got 16. Okay? So basically, this function is okay that you do this, that actually is okay. You have a polynomial function taking the so-called coefficient with x. You can represent this one as a polynomial, okay? And you print it. Now, this is actually testing the function's feature. So here I can comment it out because this two, I don't need it anymore. It's evaluation of the function. But now, last time when we do charting, we do using the x and also using the y series. Okay, series. So let's do it again. So here, let's do from high left import star Okay, so we actually define the x. So right here, we only evaluate a single point of the x as 2 or 3. Okay, but that's not what we want. We may have a x as a sequence that is from linear space. If I use a Numpy, then it will be this. So here, I want to use a Numpy as a domain name, so I do import. This is not necessary, okay? This is not necessary, but I just want to have the Numpy as NP. I want to use this NP domain name, okay? But if you just use a linear space, that's good enough, that's okay. But here I want to do Numpy the linear space. Okay, and 3 parameter is the starting number to the end number, such as 2 from 0 to 3, and then using 31 points. Okay, and then that would be that would give you the x of 0, 0.0, 0, 0.1, 0, 0.2, up to 3.0. That's totally 31 points. This is your x. That is a list. Okay, that's actually. I should say this is an array. It's not really a list, okay, but it's convertible to an array, okay. But it actually is an array. Later we'll talk about NP, okay. We'll talk about Numpy. Today we'll talk about Numpy, okay. But here, this one is the function definition. Okay, this one is a polynomial function definition that basically is a evaluation of f of x when you evaluate a certain x value. This is the function evaluation. But right here, it's actually a function as a series. Function as a series means that you do have a function. You actually evaluate a different function at different x sequence. So x is this x sequence. And then now we will get a y sequence. So the y sequence would be equal to y equals this one poly of the function that's 1 to 1, okay, and then with p value, okay, and for every t in f, okay, then this actually is you have this. Your x is here, your different x value is right here. Okay, your x different value right here, and then you do have different value here, 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 here. This different y value is your y sequence. Is that okay?
Yeah.
So here we do give you the concept of here is actually functions no value definition. Okay, and then here actually is function as sequence. Both are function definition. Both are function representation in math. You need both. You need both. Okay, and then later we plot it. We do figure. We do show. We do plot. Let's do plot. Okay, let's do plot. Your x and y, and then using blue color to plot it. Okay. Then you get. What do you get? It doesn't run. You haven't finished. Oh, it draw. Okay, so it come out. Okay. And then there is no data point. So you may want to have a data point. So you may want to use a scatter chart. X and Y. Okay. And then let's use a marker of 0. Circle. Okay. No, let's do here. Let's do red. Okay, red. Let's use a color equals red. Okay. Okay, that's 30 points. Each point of the y we need some product on it. These are the scatter part. So the line, the plot give you the trending, and the scatter point give you the data point on there. Is okay?
Yeah.
We can further beautify it, but that's not what we want to do. Okay, so this one is our first function, polynomial number one. Okay, so this polynomial, we do define a polynomial in the function, and then we do linear space. Okay, and then we do y as a sequence. So x is one sequence, y is another sequence. But this x sequence basically it is a Numpy array. Okay, so here it is a Numpy array. So today we'll talk about Numpy array later. Okay, but remember this is Numpy array. We will work on the Numpy array later. Now let's look at polynomial number two. Let's actually copy this one and then post on polynomial number two. Polynomial number two right here, I'm going to rewrite everything. So I can copy from polynomial number one. So, oh, I'm sorry. So this one actually changed the name on the wrong file. So this one is keep it as a polynomial number one. Okay. So anyway, we have polynomial number one. We are going to modify the polynomial number two. But here, this is a polynomial function. I'll keep it there. But this is a different plotting. Let me delete it for the time being. Okay, I don't need that. So this is a function. I'm not going to use it anymore. I'm going to also comment it out. Okay, now I'm going to define this function as a class polynomial as a class. Okay, so this class is a polynomial, and we will have a constructor. This constructor have the self function, so it come in with the coefficient. Okay, it will assign with the coefficient. So this coefficient would have self that here you have a class, I'm sorry. You will have a class instance variable of the C, the coefficient equals this coefficient. Okay, that's the coefficient. So you have a polynomial constructor, you will have the coefficient right here. Okay, so now you will also have, let's actually do this. Okay, so here let's actually do here let's do okay, define under the underline string, under underline this is toString function. Okay, so this toString function, let's just do return, okay, string of your self.c. Okay, you actually print out your coefficients as your toString function. Okay, now let's actually do polynomial one to be equal to what? Equal to polynomial, and then you enter the polynomial 1 to 1. Okay, then that's print P1. So this one is a simple polynomial class, and the only thing that you do right now is to print out the string. Print out the string as the coefficient string, and the coefficient string you print out. That will be the listing of its list. Oh, and then let's see. It's the list. Okay. Any questions so far?
No.
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 No. Now we are going to work on the evaluation of this polynomial, because here you do have a definition of a polynomial of C2x squared plus C1x plus C0. Now you do need to sometimes do evaluation, but now we are going to put it into the class. Okay. Previous one we represented in function. That's okay. We demonstrate in polynomial one, but now we are going to put it into the function here. So here, remember it has another magic function called define call function. Okay, so this call function will have a self and then x. Okay, so let's copy this one over. Put it over here. Okay, so the sum is the same sum. Okay, sum is the sum value you will actually call. And then this is C will be the polynomial's coefficient. So you will do length of that, and then you will be self the C coefficient times x, and doing this will be the evaluation function for this. So when we use it, what will we do? We would do here P1's okay, so let's do this. This one you will do point P1 and evaluate as the that will give you the evaluate of the function. So this is the name of the object. You use the object, then you call. When you do the object as a function, you call the call function. That's a magic function. So any function object in Python can be called. When you call this underline call function, and then your tool will be passed in as the x value. So you basically will evaluate the coefficient using the same function we use in the function evaluation over there. And then this would work. Let's do save and let's do run. This is the second version of our function. And that will give you a 9.0. That's what we need. Okay. Any questions so far?
No.
No.
No. Now these two print. This we don't need it. This we don't need it. Okay. Let's just delete them. And this is a function definition. We don't need it. In poly1, we don't have it. Okay. So we do get this one as a polynomial one. We get it again. Let's do x equals. Now, let me go back to actually we do have this. Okay. So we do numpy that linear space of 0 to 3.0 using 31 point. Okay, that's your x. And then you will do your y equals P1 of your t or t in x. Does that make sense? Does that make sense?
Yeah.
Yeah.
Okay. Now the same thing plot in polynomial one would be copied over, put it in polynomial two. So this one is the same function, but using the class as a function. So class as a function here, polynomial one is a function as a function. Okay, it's a function as a function. Polynomial two is class as a function. Either one define the polynomial function. Okay. So let's change it using the green color for the plot, okay, using the blue color for the dots. Let's make a difference here, save and run. Okay. Now this one, let's actually make a little bit of the difference. So let's actually do this. Let's do, how about I have a polynomial two was polynomial of 1 minus 2 and 1. This is the second function that we would have, polynomial function. X is the same, so y2 will be equal to polynomial 2 of the t, and then for t in x, and that's 2 plot. So finish these two, we do plot x and y2 using the rule color, and then scatter x and y2 color equals, let's use yellow for the dots, whatever. This is the second function, but we plot it as well. Does that make sense?
Yeah.
Yeah.
The yellow dot really not really showing you, not really easy to see. Okay, let's change it. This is actually, this blue is actually look like a brown. Okay, let's just use blue. Okay, I think B maybe means a brown, so it doesn't look like the one that we really like. Let me replot it again. Okay, so these are the two charts. Now, go back to the fundamental part. So the two can define, so you learn from your math course, you learn y equals ab plus ax plus b. Okay, this is first order function. You do learn quadratic function. You do learn y equals sine function. You do learn y equal exponential function. You do learn y equal log function. Okay, whatever function you can do, you can always create it as a class or create it as a function, up to you. Okay, up to you. So here we are talking about general case of how to create math function and then put into Python code. And that will help you in any of the math course and statistics course or physics course. Is that okay so far?
Yeah.
Yeah.
Okay, that's okay so far. That's okay so far. So that's so far so good. Okay, that's up to here. Now, today I would introduce, I promise you, I'm going to teach you Numpy. Okay. So what I'm going to do is the appendix section that I'm using in the robotic course I'm teaching in the Louis University. Okay, I already sent it this here, right here in the group. You can download it. Okay, the PowerPoint file I already included right there. So I'm going to, I already sent you. You can download it. Okay, if you cannot download it, let me know. Okay, but anyway, this one will teach you linear algebra. Basic, very easy linear algebra. Okay, so that's the, okay, and then why we are learning it? Because when you try to learn data science, there are three maths that's fundamental to the data science and machine learning. Three classes you must learn before you can do data science in college. Okay, this is three courses. Let's look at it. What are the three courses there? This is actually math or data science and machine learning. I'm not trying to teach you the whole math, okay? I'm just trying to give you the idea what are these three courses and give you the very basic understanding, okay? Number one is statistics. Okay, so you will take the AP stats, okay, or you will do SU 262. Okay, you would do also maybe urban ICS 7. Okay, whatever. Okay. Actually, it's not ICS, actually stats 7. Okay, whatever. These are courses you can take from college. Now, second, you will need linear algebra. Okay, this one is ASU 243, 343. Okay, whatever course. This one is very important. You will learn vector and metric from there. Third important course is you will learn multi-variable calculus. Okay, so this one would be the ASU. I forget the name, maybe 232. Okay, maybe I forget the number, maybe. This one I'm not sure. Okay, let me put a question mark over it. I'm not 100% sure. Okay, but anyway, you will need that. That's actually this one also called calculus 3. So basically, you need to finish BC and then that's a single variable calculus, and then you need to do more multi-variable version of the calculus. But what we would like to say is that, okay, I'm not trying to teach all the math right here. I'm just trying to tell you that this linear algebra is very, very important. And linear algebra coming from array and vectors. Okay, so let's get started for this part. That's what we want to do today, okay? I'm sorry, let me take a picture. These are the 3 important math courses before you do the data science and machine learning. And in a way, these 3 courses, these 3 courses are also the fundamental courses for robotics. That's what I'm teaching in this CS 65K in Louis University. This is robotics, okay? So anyway, let's get started. So linear algebra, linear algebra, first you learn what is scalar, what is array, what is vector, what is matrix, what is tensor. Okay, so we talked about it before. Scalar is a single data, so you have a 3, you have a x, these are scalar. And then array you have A0, A1, A2, whatever, these are a vector, array or a vector, right? These 2 similar names. Vector is a mathematical name, array is a CS name, okay? And then you have 2 dimensions, that's actually matrix. 3 or more dimensions, that's called tensor. Okay, this is the basic definition. So let's continue, okay? And then you can install the Plotly, okay? This one, right now we don't teach Plotly, okay? But if you are interested, you can install it. This is an advanced version of the Matplotlib, okay? But we don't need it right now, okay? So here I'm going to skip this Plotly portion, okay? So first one, let's call it, look at array, okay? So your single value is called vector. 1 dimension, you call it vector or call it array. 2 dimension, you call it matrix. 3 or more dimension, you call it a tensor. So tensor is like this, okay? So you go to your CS, or you go to robotics, or you go to data science, you are dealing with all of these different terms, terminologies, okay? So you learn physics, you learn math, you learn AI, you all need these. You all need this, okay? Is that okay so far?
Yeah.
Yeah.
And these different things, Python doesn't do it well. Python by itself, Python just give you Python just give you tuple and the list. It doesn't handle this well, so we do need this Numpy, numerical Python. Numerical Python, we call it Numpy. Okay, Numpy. So we do need a Numpy. So that's a Numpy array. So Numpy array is an array. Numpy array do have an index. Numpy array can do slicing. Numpy array can do reshaping. Numpy array can join or split. Numpy array can be work like a vector. Numpy array have the multiplication. Okay, but Numpy array cannot add or remove data. Numpy array have to go to convert it to list to do adding data or remove data and then go back to Numpy array. So there is a mechanism to transfer from Numpy array to list. So list is like vector or array list in Java. Okay. So list is of variable length, but array still fixed length. But array you have many vector calculation in Numpy domain. But list you do not have that vector operations. Okay, these are the one example. But list do have the advantage of being flexible in length. Okay, that's actually just basic definition. We will look into that later. Okay. So first, let's look at the data representation. So you have a data of Numpy array 1, 2, 3. So you create a list. So let's look at this one. Okay, let's look at this one. Okay, let's look at this one called Numpy array 1.py. Okay, let's look at Numpy array 1.py. Okay, I had the wrong name. That means remove the key. Okay. So it's Numpy array 1.py. Okay. Okay, very easy. Array A equals to Numpy that array, and you put a list over there. So 1, 2, 1. This actually, let's do import Numpy plus Numpy. This one again, if you do from PyLab import start, you do not need to have the Numpy dot. Okay, but here I want to use the domain name. So I keep the NP. Okay, so this one is the Numpy's function for creating an array, and then I can do print or it is an array, so it's the same like a list. So you can do A1. You can print your A2. Okay, array can have the index same as a list. That's no problem. And you can print A that would be giving you the whole array print now. Okay, so you can also do A list equal to this conversion to A to here, and then you can do A list that no, not add, it's 10 4. And then you do convert it back to equals NP.array A list, and that's print E. Okay. So this one is it is saved, and that's wrong. So what happened is you print now A1 is 2, A2 is 1. Okay, this is the print now. And then you print now A A is the Numpy array. So you print now A is 1 to 1, okay? And it is in this format, 1 to 1. So this is the array format you can print now. Now again, because array you cannot append data to it. So if I want to append the data, I convert it back to the list and then use this append. So I append a 4 to there and then I convert it back to array. Okay. Then I actually do multiplication of my data. So the B is like this. Any questions so far?
No.
So now you actually learn one more thing. You actually learn you have tuple. Tuple is actually using parentheses. And then you may have a list that's actually 1, 2, 3, 1 to 1. Now you have one more data type that called Numpy array. Okay. So again, now here, let's do this. Let's do for each x in B. Okay, you still can do the follow. So B is an array. B is also iterable. Iterable, then you can put it into the for loop. Is that okay? Any question?
No.
No? Okay, no, good. Now, next one, we will look into the function because it's a Numpy array. So there's a function called maximum you can do. That's instance function. So you can do print b.max. Okay. If you do Python, then Python function you can do max of a list. But right here is an instance function, so you do call the max function by the object of the array b. Okay, and then you run, it will give you the 4. You give you the 4. Okay, it will give you the 4. So that is the maximum function. You can also do the minimum function. So that's the function coming from Numpy array. So this is a maximum linear function. The list in the Python doesn't have, okay. They do have the function in the math module, but it doesn't come from the object itself, okay. But Numpy's array do have that, okay. Anyway, so this is Numpy array. So there's a n time, there's a shape, there's a size, there is a D type, there's an itemized. Okay, n time is the number of the dimension. So right here we are using the 1 dimension array. Okay, so let's do another one. So let's do this. Let's do, okay, this is for NP array number 1. Let's let you copy and then paste. Okay, then change it to this one. Let's do NP array 2. Okay, so here NP array 2. This one I'm going to create something called metric. Okay, so let's delete everything else. So here I'm not going to do it this way. So here I'm going to create a metric. Okay, and this metric is, let's assume it's actually called 1, 2. Let's call it 1, 2, 3, 4. Okay. So this 1, 2, 3, 4 actually creating a metric of 1, 2, 3, 4. It's an NP array, but this is 2-dimensional array. It's actually a matrix. So you do print n dot n time. Okay, so print now the number of dimension for this matrix. Okay, and then you can also print matrix 0, 0. 0, 0 will be the element of this one. Okay, you can also print This one, the size. Size is the total length that you have. So let's print out these three things and see what happens. Oh, there's no size. Let me see. One moment. Net number of the element. Yeah, they do have a size. Oh, I'm sorry. It's not a function. It's a parameter. I'm sorry. It's a parameter. Okay. So it actually is a instance variable. It's not a function. Okay. I'm sorry. So you do print out the dimension. Dimension is 2. M00 is actually you have a 1, 2, 3, 4. So this 2200 location is 1. The size is 4, totally 4 elements. Is that okay so far?
Yeah.
Some of you may not learn the metric before. Okay, if you haven't learned the metric before, so these are 2-dimensional array. Okay. So far, okay.
Yeah.
Okay, so these are some number later you may need it. Okay, I just go through undyne, size, shape. I'll talk about it later. Okay, shape actually you will give you the width, length, height, and plane. Okay, so that's actually look at it. So here, if you do print the shape, okay, so that's print and the shape. Let's see what will happen. It actually will give you an array. Okay, it will give you a list. It will give you a list of a tuple actually. It's actually 2 by 2. So 2 row, 2 column. It give you the 2 by 2. Okay? Is that okay?
Yeah.
Yeah.
First number tell you how many row and second one tell you how many column. Okay. So that's called shape. It's available that you can get. Okay. So this one is the advantage of using empty array. Okay. So right here, let's look at it. There's one example. So this one is a very, very fundamental math part for the data science. Okay, that's why I'm teaching you here. So you can do A range 6. A range 6. Remember your range function. Okay, so A range 6 will actually create a range function of 0, 1, 2, 3, 4, 5, 6. 0 to 5. Okay, so your array is like this. So this is 6 will create a range function of 0, 1, 2, 3, 4, 5, just like your range function. Is that okay?
Yeah.
Yeah.
And then this one is actually 1-dimensional array is 0, 1, 2, 3, 4, 5, 6. You reshape to 2, 3. 2, 3 means that 2 row and 3 column. So you put into this 0, 1, 2, 4, 5, 6. So this is reshape. And you're going to print out the shape, print out the undyne, print out the size. Let's do this. Okay, this one actually is 2 by 2. Let's do this. Let's go back. Let's actually create another one called NP array 3. Okay, NumPy array 3. So let's do NP array 3.py. Okay, now let's create a matrix. Okay, using NumPy.arange. Let's put in a 9. Okay, so import the NumPy as NP an arange of the 9. So you create a sequence of 0, 1, 2, to 8. Okay, and then do m equals m that reshape of your size of 3 by 3. So remember the previous one, you put the shape of 2 by 3. Okay, now let's put it 3 by 3. And then let's pull in this metric M. Then you will get what? You get the 2-dimensional metric of these. Is that okay?
Yeah.
So you can do your pulling your n time. There's a number of dimension. You can put in your m's shape. So m's shape will be 3 by 3. Okay, n time will be 3. Number of dimension is 3. Okay, so that's just a organization of the data. Okay, whatever that give you a quicker way of organizing your matrix. Is that too hard to so far, or is that okay?
No. It's okay.
Okay. So a array, okay. So right so far we use an array, and you can load a list to become a matrix, an array, okay. And then we also teach you a range to create a range function for the elements. Okay, that's another one. That's actually, there are some other functions that create array. Okay, so now next one is ones, zeros, and randoms. Okay, let's look at these 3. Okay. So now let's actually create another one that's called A1 equals Numpy that zeros of 4, the print your A1. Okay, so far. So you print out 4 zeros in the array. So remember that when you do list, you would like to use list. That's as soon you have a list of X, and then you would like to create 4 elements. You have to do this, right? You remember that? A list of 4 zero, you do this, right? Is that okay?
Yeah.
Or you will do this for I in range of 4. You will create 4 zeros. But that's actually wasting time. You actually just do, you can use 0 or 4. Okay, that's actually the zeros function. So zero function is the same as array function, except that you put everyone with 0. So let's do A2 equals MP that ones of 4. You put in your A2. So A2 will be filled with what? With all 4. Okay. Now let's do this. Let's do A3 equals numpy the random 5. This will create 5 random number, and that 5 number will be from 0 to 1. Okay. So let's print A3. Okay, so these are 5 elements of random number from 0 to 5. Okay, 0 to 1, okay, by element. Now you may want to have a random integer, so you do numpy array of random integer. So run random integer, random int. So you do low, high, size. Okay. Low, high size. Low, high size. Okay, low, high size. Let's do A4 equals numpy that random integer starting from 0 to 10, and then size of 3 in A4. So totally will be an array of 3 elements, and each one coming from 0 to 10. Okay. This one is more practical, okay? Is that okay?
Yeah.
3 elements of 0 to 10. So sometimes you may want to create scores equals numpy that random integer starting from 0 to 100 and then 5 subjects. So this is a print scores. This is a quick way to generate 5 number of the random value. Okay, so far that's actually sum up. Here you do have a array that you can load so far we already learned array that you can load some list into it. You can use a range to create a range function. You can put everyone with 0. You can basically put ones into there. You can put random values from 0 to 1 there. You can put random integer into there. You can also do x equals numpy of the linear space from 1 to 10 with 10 numbers. That would be 1, 2, 3, 4, 5, 6, 7, 8, 10, right? And then that's print UX. That's another way you can generate an array. They are all arrays. They are all arrays of the same type. Different way of generating an array. Is that okay so far?
Yeah.
Yeah.
This one gives you a lot of freedom to create the numbers that you want for data science, okay? That's the purpose of why we are doing this kind of array right here, okay? We don't teach you the basic Java. I'm sorry, I don't teach you the basic Python array. That's too simple. That's of no practical use. Okay. Here we teach you more advanced version of the Numpy. And you can convert it back to list if you like. Okay. You can convert it back to list if you like. And then there are eigenvalue that you can calculate once like 0, 4, or whatever. Okay, these are different things. You can check if the array is empty. Okay, full, whether it's full or not, with data or not. Okay. And then numpy's data type you have can put byte short or long like C language. Okay. Too much. Okay, this one I don't emphasize on this one, but these are the data type you can put into your numpy array. Okay. Okay, next one you will do arithmetics. So that's the reason you have the data 1, 2. Okay, or you do ones, you have 1, 1, okay, whatever. Now, so your data plus 1, it will be your data this plus this this plus this. You have 1, 2 plus 1, 1. You end up to 2, 3. Okay. So let's do this in the program. Okay. So this one, let's call it Numpy array 4. We do arithmetics, okay? Okay, let's actually do Numpy. Let's do A equals Numpy that array of the 1, 2, that's 1, 2, 3. Okay. Then you have another one called P equals Numpy that ones of the 3. Okay, let's do print your A and print your B. And let's do C equals A plus B. Then you print your C. Okay. Let's do this. Let's do A equals. Okay. Let's do B equals. Okay. And here do A plus B equals. Okay. Oh, okay. To import NP as NP. Okay, sorry for that. I forget to import. So your A is 1, 2, 3. B is 1, 1, 1. So you actually sum up 1 with 1, that's 2. 2 with 1 is 3. 3 with 1 is 4. That's your A plus B. So you have 1, 2, 3. Sum up with 2, 1, 1, 1. Then you get a result of 2, 3, 4. Is that okay?
Yeah.
Okay, so that actually is vector processing, vector sum, okay? You can divide it. You can multiply it as well. Multiply means that first one multiply with the first, second one. Second one multiply with the second one. Okay. So let's do this, okay? Here let's do, we have A equals 1, 2, 3. That's actually have another one, let's call it C, ABCD equals Numpy, that array of 1, 2, 3, okay, and then let's do E equals A times D, and that's a print E equals E. So A is 1, 2, 3, D is 1, 2, 3, so your multiplication result would be 1, 4, 9, the square of them, because 1, 2, 3 times 1, 2, 3, you got 1, 4, 9. Okay. Any questions so far?
Yeah.
So Benjamin, what kind of multiplication is this? Do you know? You have A array multiplied with B array. You A0 times D0, A2 times D2, A3 times D3. What's this kind of a multiplication? How about Sherry, do you know? How do you call it? How about Sherry, do you know? Hello?
Like squared?
No, it's not called it squared. Anybody know? Because Belinda and Liana may not learn this yet, but you may not take the physics course yet, so I don't expect you know it. Okay, this one is called inner product. What is inner product? You do have AB dot CD is equal to. Oh, okay, no, it's not inner product. I'm sorry. Inner product is AC plus BD. It actually is one value. No, this is not. This one is actually production. Just this is not inner product. I'm sorry. This is wrong. This is wrong. It's just per element multiplication. Okay, it's actually per element multiplication. But as you can see, if you do it by array or by list, you will do for loop. That will take a longer time. Okay, this one just give you per element multiplication. Now let's try another one. How about you if you have the 1, 2, 3, but you time a number of A here? What will happen to the result? It become 1A, 2A, 3A. If you time a scalar, okay, so let's do this. Let's do S equals 4. And then let's do A4 equals A times S with A4. This one is vector multiply a scalar. It is a 1, 2, 3 times a 4. You got this, okay? Any question? Any question?
No.
No.
Can we do this? Can we do R4 equals A4 K modular by 4? You got O0. Why is O0? You see, it actually you do have 4A12. You K modular by 4. It becomes 4 mod 4 A mod 4 12 mod 4. So it's a per element operation of this. You apply this to here, to here, to here. Is that okay? Is that okay?
Yeah.
Yeah.
Let's try another one. Let's actually here, let's do define square x return x times x. Okay, so here I will have a actually ES equals square of your A print ES. Your function is a single element square, but you put a vector into there. So this square will perform on each number, and you will get this. What does this mean to you? Your function is a square, and you enter a 1, 2, 3 to there. So you put into a square function for this scene. You actually square on 1, square on 2, square on 3, and then make it an array. Is that okay? Does that make sense?
Yes.
Okay, now this one give us a good idea. So let's assume that our x is equals NP, the linear space from 0 to 10, and then 11 points, right? This is 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, right? Is that okay?
Yeah.
Yeah.
My y will be equal to square of my x. And then let's do figure. Let's do show. Plot x, y, and then with scatter x, y, and then with what does this mean to you? It means that if you have a Numpy array, you directly put into a scalar function, the scalar operator would operate on each of the array element, and the output will become an array as well. Does that make sense?
Yeah.
And you remember its operator is the same. It will operate on each element. So this function will take on every element as well. Right here, figure, let's see, figure is wrong. Oh, I'm sorry. Figure is wrong because I forget to in Copilot. So in a way, what we actually learn right here, okay, we do have a poly 1, poly 2, right? Poly 1, poly 2 give you the using the polynomial function to define the polynomial function. Poly 2 give you the so-called class to define a polynomial function. Now, this lumpy array here, you can define a scalar function and you can put your input vector there. You will actually also get the output vector, and this is a sequence format. And you can mimic the function by this as well. Okay? That's what we learned so far. Even using array can also mimic the function or scalar functions. Okay, that's actually very convenient. Okay. I'm trying to teach you the very useful rules when you go to the math, okay? When you go to the math. So you have the parallel processing, you have a scalar operator. Now let's do indexing. Indexing is the same as the slicing that you have in Python. So this one, we don't emphasize it, it's the same. Whatever indexing you can do by slicing, array all enjoy it, okay? Array all enjoy it. I think I don't need to tell you too much, okay? This one, from -1 to -9, each time jump by -2. So it's done counting, okay? You actually just figure it out, okay? Next one is array do maximum, minimum, and sum. Okay, this one is aggregate, doing this different function. I think it's okay. You do know it, okay? This one, you can do the sum, the max, the mean, the average, the mean, the median, by standard deviation, the variation. Okay, these are the statistical function. The Numpy all have it. Any questions so far?
No.
You don't need to design these different functions. They do give you the sum, max, mean, average, mean, the median, standard deviation, variations. If you don't know what it is, you can just search for Numpy definition of these different functions. These are the basic statistic package. Okay? Okay. I don't waste time to explain this. Okay? These are statistics terms, so I don't go into there. So 2D arrays as a metric or a table. So you can do 2D array creating a metric. And then you can do all ones, all zeros, all random values. Okay, this two-dimensional array. And two-dimensional array, whatever. And then you can do this one plus this one, this one plus this one, this one plus this one. That's just like your vector as well. Okay. That's vector processing, parallel processing, okay? You don't need to do for, you just do A matrix plus B matrix. The corresponding location will process again, okay? And if you do a matrix plus a row, then this one plus to the first row, plus to the second row, plus to the third row. It's just like this. Is that okay?
Yeah.
Yeah.
So if you plus a value A, it will be this one plus A, this one plus A, this one plus A, this one plus A, this one plus A. So if it's a scalar lower dimension, you plus to everyone. If you have an array, then you will plus to row by row basis. Okay, this is how it works. Oh, okay. Here that is the inner product. Okay, inner product is right here. Okay. So this one you will have one, this one is inner product. So this one times this, okay, is 1, 2, 3 multiplied by 100 and whatever. So it's multiply this one with this one. Okay, and this one with this one. This is inner product. So actually 1 by 3 times 3 by 2, you end up with 1 by 2 format. Okay, is that okay?
Yeah.
This is dot product. We also call it inner product. Okay. So if you don't know about what inner product is, maybe later. Okay, I just skim over this. We don't actually force you to learn it yet. Okay, you just need to know it. So we don't emphasize on this one. Okay, whatever. A metric indexing, you can do this. You can also do this. Okay, you can do 0, 1. You can also do 0, 1. Either way is okay. Slicing still work for 2-dimension or more dimension. Okay. You still have the max, min, sum. Okay, for metric. And you can do maximum on the on a certain x is equal 0, that's actually this column. Maximum is equal 1, this equal this rows are maximum. Okay? Any question?
No.
So your maximum on the column is actually this, you get this. Row is this, so get the maximum of this, okay? It's actually x is maximum, minimum. Okay, just give you the idea of what it is, okay? And then next one, you can do transpose. You have the 3 by 2, you change it to 2 by 3. It's that T, you do transpose. Okay. This one's metric operation. Later you will know how this one is useful. Okay. Just remember you do have this kind of operations. You can do reshape, 1 dimension reshape to 2 dimension. Okay, to come 2 by 3 or become 3 by 2. Okay, reshape. Okay, and you can create multiple dimension array. Okay, using the shape available. These are shape available. 4 by 3 by 2. 4 by 3 by 2. Okay, it's a multi-dimensional data. Okay, reshape and rebel. Okay, whatever. Okay, this part I see too hard, so we don't go to this deep. Okay, and they are flatten way to flatten the data out as well. Okay, anyway. Insert and delete of the row, you need to convert it back to the list. And then do insert and delete in list level and convert it back to array. Okay, so this is append using append function. Okay. Okay, this one I don't emphasize. Okay, this one you just look at it when you later you can read it. Here, let's see. You can do some mathematical operations on it. Okay, right. This one I don't go too deep into here. Okay, you need to learn some math before we study this. So this one mean square error. Okay, mean square error. You just remember there's something more we can do. And this kind of array operation, you can use it for music file, for audio data, image data for 2-dimension or language data. Okay, you can load a music file and read it as a CSV file. Okay, and you need to process it on it. Okay, whatever. So these are more advanced topics. You can load the audio data into it and put it into an array. Okay, you can load a image data into a 2-dimensional array matrix. Okay, and color image or 3 color plane, red, green, blue plane into a image. Okay. And they are more matrix operations. So here we don't emphasize on it. Okay, this is actually too much right now. Okay, this actually the whole material is prepared for robotics. So that today I'm not trying to introduce the robotics to you. Okay, that's too much. Okay, that's too much. But what I want to say is that I give you the basic idea of what is linear algebra, and also put it into our Python Numpy, okay, and give you the idea of how to represent function and vector input into the function and create corresponding functions. Is that okay?
Yeah.
And the rest of them, maybe depending on later when you have more math, you will be able to study this one and maybe move on to robotics, okay? But today we just give you this short introduction of this math part. Okay, and then basically give you the idea of how to use the function. So this one we are okay. we finished the basic operation on the linear algebra and data science. Okay, now let's go back to the chapter 7 and 8. Let's go through the slices, making sure you can answer for the functions. Okay, for your questions. So the basic if then else is simple. There's only one thing that I would like to mention in this chapter. That is the try except. That is the try except. Okay, try except is the exception handling. This one we haven't touched yet. Let's talk about this try except. Okay, so you may do this. You may do a equals integer. Okay, you do input. Right. Okay, you may do this, but sometimes you may have a error that's actually wrong in terminal because this need a new input, so that's wrong in terminal. So let's do Python except 1.py. And it requires integer, so I type 10, that's actually no problem. Okay, let's do Python and then except 1.py. And if I enter a 3.3, then you would have error, right? You would have error and the program will break, right? In this case, it doesn't work. So I may want to have a mechanism that will actually handle it. So that's called try except mechanism. Okay. So this one you assign it to here, but because you want to try it, so you declare it in the outside and you do try, and then n equal this. Okay. And then this one need to follow by except. Okay, so this one, when you read the data to A, but if it fail, you actually go to the except part. Okay. If it doesn't fail, you will actually do it regular way. Okay, so if it doesn't fail, then we'll print A. Otherwise, you will do this, you will do print. Okay. So this one is you do have A equals 0. You come to here to try the input or convert the input to the integer and assign it to A. If there is something wrong, then you go to the except part. If no, you directly just print A. If yes, you do except part and then you finish the program. Is that okay so far?
Yeah.
Yeah.
Okay, so here you do except, and then that's actually save, and that's wrong. Oh, I'm sorry, I make a mistake. Let's actually save. Let's you go to terminal, okay? Because the wrong code cannot take the input. I'm sorry. So this one is except 1.py You enter 3.3, you get the input error, okay? And you do Python set on the PY, you get 3, you pass, okay? So if you do correctly, you go to here and then get out. If you have the error, then you will go by this. You will go get the input, but the input have the converted integer wrong, so you go directly to the except part. Okay. So this try except. One more thing right here, because it actually will raise an error. So this one is actually the value error. Sometimes it's a name error, sometimes it's a value error. Okay, but this one is a value error. So let's try value error. With or without it, if you don't have the error type, every error you will accept. Okay, but here we specify the value error. That's also okay. If you look at into your Python's solo learn, they do teach you this. Okay, they do teach you this. So let's do 3.3 is a value error, so it still would be pick up. Okay, so here value error. Okay, any questions so far?
No.
Okay, so if you don't do this, you do just accept, that would take all of the error. Okay, right here I just specify the error type, but it's not necessary. Okay, right here it's not necessary. So let me copy this one to paste. Copy this one to except number 2. So, but sometimes you don't like it, okay? Sometimes you don't like it because you may not want to just get the error. You may want to take it, so you will actually keep entering until you get a wrong value. So right here, usually we do down equals false. So do while not done. Okay, and then put this trial sense inside here. Okay, if you do it correctly, then your down will be equals true. Otherwise, you look back to read it many times. This one is a input validation loop. When you get things correctly, you will print your A. It's okay. This is the second version of the try except loop. So regularly you try here, and then if you successfully do it, you say done is true. Done is true, you go back. It's done, you get out. Okay. If it is not done, you actually try, it had an error, you come to here, you go back to get the input again. And still error, go back, take the error, take the value again. Okay. So this one is actually saving. This one is except 2, okay? So here to replace except 2 that you right. Oh, Python except 2 that you right. Oh, I misspelled it. Let me actually rename it, okay? Okay. So take an integer, let's try 3.3, 4.5, whatever. Okay, you will actually look back and ask for a number until you get a new one that's 2, 3, and then you pass. Okay. One thing that you must remember is that you must define a equal 0 over here, because this one is an outside variable. If you do not have this a equal 0, this a will be local variable. It's only here. It's only visible here. When you print a, you cannot see it. So you must remember to define a global variable outside before you do this try loop. Is that okay?
Yeah.
Same thing for this down equal false and down equal true. Must define over here. You cannot do it just inside. Then this here you won't see it. Okay. So this is called input validation loop. Okay. So this one, chapter 7, I just want to mention this part. Other than that, it's easy. I don't repeat, okay? I don't repeat. Maximum of the 3, okay? This one, you can use a function, you can use a if then else. So I don't explain it anymore, but you can study it, okay? Okay, that's chapter 7. Let's look at chapter 8, okay? Chapter 8 is while loop, for loop, okay? And we do show you a loop today that is the calculation of polynomial, okay? We do show you a loop today. And more loop defined, we teach you in AP Comsci A, okay? So right here, this one, for loop, infinite loop. Let me see if there's something I need to teach it, okay? Iterative sentinel loop. I think this we all cover in with lesson 4. While loop. Okay, while loop next week we will redo it again. Okay, right here, let's don't do it. Nested loop. Okay, so this one actually, let's do this. Okay, let's do this. This chapter I don't say is completed. Okay, so next week we will go over this chapter again with the file input. Okay, with more file data. Okay, we cannot finish it today. Okay.
Okay.
Okay, so chapter 8 we don't finish it. You work on the chapter 7 homework. Okay. Any questions so far?
No.
No. Now, next week we will work on the file input and we will read more data from the file and process it, put the data into classes. Okay, and we may also read in JSON data. Okay, JSON data. We will read in JSON data. Okay. Okay, good night then. Bye bye.
Bye.
Thank
Yeah.
you.